we're asked to graph the function y is equal to 2 sine of negative x on the interval, the closed interval, so it includes the endpoints, negative 2 pi to 2 pi. So to do this, I'm first going to graph the function y is equal to sine of x, and then think about how it's changed by the 2 and this negative in front of the x right over here. So let's do y equal to sine of x first. So let me draw our x-axis. Let me draw the y-axis. Y-axis, pretty straightforward. And we care about it between negative 2 pi and 2 pi. So let's say that this is negative 2 pi. And then this right over here would be negative pi. This, of course, is 0, 0. Then this is positive pi, and then this right over here is 2 pi again. This right over here is 2 pi. And then this could be 1, this could be 2, this could be negative 1, and this could be negative 2. And let me copy this thing so I can use it for later when I adjust this graph. So let me copy. All right. So let's think about sine of x. So what happens when sine is 0? When sine is 0, when x is 0, sine of 0 is 0. Sine of 0 is 0. And I'll draw a little unit circle here for reference. This is what I like to do in my head as I'm trying to figure out the value of the trigonometric functions. So this is x, this is y. Draw a unit circle. And remember, over here, x is referring to the angle. So that's my unit circle, radius 1. So when the angle is 0, sine is going to be the y-coordinate here. So sine of 0 is 0. When, as sine increases, we go up all the way to sine of pi over 2 is 1. So sine of pi over 2 is going to get you to 1. Then you go sine of pi, gets you to 0. Sine of 3 pi over 2 gets you to negative 1. And then sine of 2 pi gets you back to 0. So if I were to graph it, it looks something like this. So this is between 0 and 2 pi. It looks something like that. And we also want to go in the negative direction. So as we go in the negative direction, so we go in the negative, sine of negative pi over 2. Negative pi over 2 is negative 1. Negative pi over 2 is negative 1. Then you go back to negative pi, go back to 0. Negative 3 pi over 2, you're going all the way around like that. That gets you back to sine is equal to 1. So sine is equal to 1. And then you go 2 pi, sine is back equaling 0. So the curve will look something like this in the negative. So as we go from between 0 and negative 2 pi. 0 and negative 2 pi. And this is consistent with everything else that we know about sine. The period of sine of x, well, you see here you have a coefficient of 1 here. So the period is just going to be 2 pi over the absolute value of 1, which is a little bit obvious. It's just 2 pi. Or you just see here that the period was 2 pi. It took 2 pi length to do one of our smallest repeating pattern right over here. So and what is the amplitude? Well, we vary between 1 and negative 1. The total difference between the minimum and the maximum is 2. Half of that is 1. Or another way of thinking about it, we vary 1 from our middle point. So that was pretty straightforward. Let's change it up a little bit. Now let's graph y is equal to 2 sine of x. 2 sine of x. So let me put my little axes there. My axes, I want to do it right under it. And so what is going to happen? What is going to happen now that we have y is equal to 2 sine of x? How is the graph going to change? Well, all we did is we multiplied this function. All we did is multiplied this function by 2. So whatever values it takes on, it's going to be twice as high now. So 2 times 0 is 0. 2 times 1 is now 2. 2 times 1 is 2. 2 times 0 is, let me be careful, 2 times 1 is 2. That's at pi over 2. 2 times 0 is 0. 2 times negative 1. 2 times negative 1 is negative 2. Negative 2, 2 times 0 is 0. So it looks something like this between 0 and 2 pi. Between 0 and 2 pi, it looks something like that. And we could keep going in the negative direction. 2 times negative 1 is negative 2. Negative 2. 2 times 0 is 0. 2 times 1 is positive 2. 2 times 0 is 0. So in the negative direction, it looks something like that. My best attempt to draw a relatively smooth curve. Hopefully you get the idea. So it would look something like that. So what just happened? Well, the difference between the minimum value and the maximum value just increased by a factor of 2. The total difference is 4. Half of that difference is now 2. So what is the amplitude here? Well, the amplitude is 2. So the amplitude, you could view it as the absolute value of this thing. This absolute value of 2 is now equal to 2. And it's common sense. The amplitude here was 1. And now you're swaying from that middle position twice as far because you're multiplying by 2. Now let's go back to sine of x. And let's change it in a different way. Let's graph sine of negative x. So let me once again put some graph paper here. So put some graph paper here. And now my goal is to graph y is equal to sine of negative x. So for at least the time being, I got rid of that 2 there, and I'm just going straight from sine of x to sine of negative x. So let's think about what the values, how the values are going to work out. So sine of, when the x is 0, this is still going to be sine of 0, which is equal to 0. But then what happens as x increases? What happens when x is pi over 2? When x is pi over 2, the angle that we're inputting into sine, we're going to have to multiply it by this negative. So when x is pi over 2, we're really taking sine of negative pi over 2. Well, what's sine of negative pi over 2? Well, we could see that right over here. It's a negative 1. It's negative 1. And then when x is equal to pi, well, sine of negative pi, we already see is 0. When x is 3 pi over 2, well, it's going to be sine of negative 3 pi over 2. Which is 1. And once again, when x is 2 pi, it's going to be sine of negative 2 pi. Sine of negative 2 pi is 0. So notice what was happening as I was trying to graph between 0 and 2 pi. I kept referring to the points in the negative direction. So you can imagine taking this negative side right over here, between 0 and negative 2 pi, and then flipping it over to get this one right over here. That's what that negative x seemed to do. And by that same logic, when we go in the negative direction, you say, when x is equal to negative pi over 2, well, you have that negative in front of it, so it's going to be sine of pi over 2. Well, it's going to be equal to 1. And you can flip this over the y-axis. So essentially what we have done is we have flipped it. We have reflected the graph of sine of x over the y-axis. This is the y-axis here, of course. So we have reflected it. Over the y-axis. So let me make sure so it looks something like this. This is the y-axis. It's hopefully you see that reflection right over. That's what that negative x has done. So now let's think about kind of the combo, having the 2 out the front and the negative x right over there. So let me put our graph, my little axes there one more time. And now let's try to do what was asked of us. So I'll do it in a new color. I'll do it in blue. Now let's graph. So this is our y-axis. This is a y-axis. Let's graph y is equal to 2 times sine of negative x. So based on everything we've done, how will this look? What are the transformations we would do if we're going from original sine of x to y is equal to 2 sine of negative x? Well, there's 2 ways you could think about it. You could either take 2 sine of x. So here we multiplied by 2 to get double the amplitude. And you could say, well, I'm going to now flip it over to get the negative sine of x. And so if you did that, you would get, so let me make it clear what I'm flipping. So if I took between 0 and negative 2 pi, and I were to flip it over, what used to be here, you flip it over, you reflect it over the y-axis, and you now have, so it'll go negative first, then go back to 0, then it'll go positive, and then you get right over there. So all I did to go from 2 sine of x to 2 sine of negative x is I just reflected over the y-axis. And then, of course, what is between 0 and negative 2 pi, you just have to look between 0 and 2 pi. So now it's going to go up, up, and down. Let me make it a little bit better, draw a little bit neater. And then down, and up. So it was a reflection of what was between 0 and 2 pi. So you see that right over here. Or if you start with sine of negative x and you go to 2 sine of negative x, notice what happens between sine of negative x and 2 sine of negative x. What's the difference between this graph and this graph? Well, we just have twice the amplitude. We're multiplying this one by 2. We're multiplying this one by 2, and so you get twice the amplitude. So the last thought or question I have for you is how does the period of 2 sine of negative x, how does that relate to the period of sine of x? Well, there's 2 ways to think about it. We could, well, actually, I'll let you think about that for a second. Well, there's 2 ways to think about it. You could refer to the graphs right over here, or you could think about the formula, which is hopefully a little bit intuitive right now. If you wanted to refer to the kind of classical formula, you would say the period is just going to be 2 pi, and you divide by the absolute value of the coefficient to figure out how much faster are you going to get to 2 pi right over here. So the absolute value of negative x, or the absolute value of the negative 1 is just 1, so you get 2 pi. So you have the exact same period. You have the exact same period as the period of sine of x. And you see that. You complete one cycle every 2 pi. One cycle every 2 pi. One cycle every 2 pi. Now, what is the difference? Well, the period's the same, but remember, this negative x, it's not like you can just completely ignore it. It doesn't change the period, but it does change how the graph looks. When you start getting increased x's, instead of sine being positive, as it would be in the case of the traditional sine function, here, as x grows, you're taking the sine of negative x. So you're taking the sine of a negative angle, and so that's why you start off having negative values of sine. And that's also another way, if you want to think about it, that it's the reflection over the y-axis of just sine of x. These 2 are reflections, and these 2 are reflections. This one is 2 times the amplitude as this one. This one is 2 times the amplitude as that one.